Welcome to welcome to my YouTube channel. I am discussing solid state physics concepts. So in last videos I discussed about what is lattice, what is crystal. Crystal is consist of lattice plus basis. So like that I discussed some concepts, primitive unit cell. So today in this video I want to discuss about different crystal systems. Different crystal systems. So I want to discuss here 7 crystal systems and 14 Bravell lattices. 14 Bravell lattices. So how do we classify? In each system, how many Bravell lattices are there? So these are I want to discuss here in this video. So look here, first one cubic. First one is cubic. This is first crystal system. This is the first crystal system. So Bravell lattices, how many Bravell lattices cubic system have? Only one. That is simple. That is simple cubic. Simple cubic. So we can denote with the symbol P. We denote with the symbol P. See, I am discussing here cubic crystal system. The Bravell lattices for this cubic, simple cubic, that is P. Then, so what are the characteristics of unit cell? So unit cell characteristic A equal to B equal to C, then alpha equal to beta equal to gamma equal to 90 degree. A equal to B equal to C, then alpha equal to beta equal to 90 degree. So here for Bravell lattices for cubic, so simple cubic it exists. Then one more base body centered cubic. So this for this symbol I. Then one more centered face centered, that is symbol F. So in cube, that is cubic, that cubic system, it has Bravell lattices, three Bravell lattices. One is P, one is second one is I, third one is F. P I F. So for cubic system, crystal system, it has Bravell lattices, simple cubic, body centered cubic, face centered, PIF. So the unit cell characteristics A equal to B equal to C, alpha equal to beta equal, that is equal, gamma equal, that is equal to 90 degree. So examples 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 for cubic system. So here aram silver aram silver, then copper, then then ferrous, then one more NaCl, sodium chloride, zinc sulfide, and diamond. See, I discussed here one crystal system, that is cubic crystal system. I discussed. So it exists in Bravell lattices, simple cubic, body centered cubic, face centered cubic. So Bravell lattices for cubic crystal system, that is PIF. It exists in three Bravell lattices. So unit cell characteristics. A equal to B equal to C, alpha equal to beta equal to that, gamma equal to 90 degree. These examples, these metals, these compounds exist in cubic system, that is AuRm, silver, copper, ferrous, sodium chloride, zinc sulfide, diamond. So I discussed here only one cubic system. The second one I want to discuss here. That is second. First crystal system I discussed here. Next one, tetragonal. Next one is tetragonal. Tetragonal. Tetragonal system. I discussed cubic crystal system, then tetragonal system. So Brave lattices for this system. Brave lattices for this system. So tetragonal here, simple one, simple tetragonal, then body centered, then body centered, tetragonal. See, I finished cubic system here. See here I am discussing tetragonal system. The Brave lattices for this system, simple tetragonal, body centered tetragonal. So two Brave lattices exist here. Two Brave lattices exist in tetragonal system. Then what about unit cell characteristic? What about unit cell characteristics? A equal to B, A equal to B, not equal to C. A equal to B, not equal to C. Then what about angles? Alpha, that is equal to beta, that is equal to gamma, that is equal to 90 degree. See here, alpha, beta, gamma 90, there is no change in A equal to B equal to C, but here A equal to B not equal to C. So some compounds exist in tetragonal crystal system. For that one, examples, beta tin, beta tin, beta tin, that is in white, beta tin. Next, titanium oxide, tin oxide. So these compounds exist in tetragonal system. So I discussed here second crystal system. Brave lattices for this system 2, that is simple tetragonal, body centered tetragonal. Okay, next I want to discuss one more crystal system, that is orthorhombic. 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 C T O. So orthorhombic. This is third crystal system. In third crystal system for orthorhombic, what are the Brave lattices? Brave lattices. How many Brave lattices for orthorhombic crystal system? See, this is first one, simple orthorhombic, base centered, orthorhombic, then body centered orthorhombic, then one more face centered orthorhombic. See, third crystal system, that is orthorhombic system. Brave lattices for orthorhombic system, one is simple orthorhombic, base centered orthorhombic, body centered orthorhombic, then face centered orthorhombic. So how many Brave lattices in this system? 4 Brave lattices exist. So for this one, so what are the unit cell characteristics? See, A equal to B equal to C, this is cubic. A equal to B not equal to C. Here I am mentioning A equal to B not equal to C. Then alpha, beta, gamma equal to 90 degree. So here, what about examples? Which compounds exist in orthorhombic crystal system? So for those examples, potassium nitrate, potassium nitrate, potassium sulfate, potassium nitrate, potassium sulfate, alpha sulfur, gallium, Fe3C, that is cementoid. See, in orthorhombic system, these compounds exist in orthorhombic crystal system: potassium nitrate, potassium sulfate, alpha sulfur, gallium, Fe3, that is cementite. So what is I discussed here? Three crystal systems up to now. For this shortcut CTO: cubic system, tetragonal system, orthorhombic system. I am moving to fourth crystal system. Fourth crystal system, that is rhombohedral. 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 Do you know rhombohedral? That is nothing but trigonal. That is nothing but trigonal system. So rhombo, rhombohedral or trigonal system. Trigonal system. So for this rhombohedral or trigonal system, what are the Breve lattices? Breve lattices. So here Breve lattices only one. Simple rhombohedral. Only one Breve lattice exists here. Simple rhombohedral. Simple rhombohedral. That's it. Simple. So what about unit cell characteristics? What about unit cell characteristics? So here A equal to B equal to C, alpha equal to beta equal to gamma, alpha equal to beta equal to gamma. These three are not equal to 90 degrees. These three angles not equal to 90 degrees. See, I am discussing here rhombohedral or trigonal cubic system. This Breve lattices for this one simple rhombohedral only. Unit cell characteristics A equal to B equal to C, alpha equal to beta, that is gamma not equal to 90 degree. So examples, which compounds are exist in rhombohedral or trigonal system? Those are arsenic, arsenic, then bismuth, calcite, CaCO3, calcite. So these compounds exist in rhombohedral or trigonal system. Rhombohedral or trigonal. This is the fourth system. So I discussed here. Then we are moving hexagonal system. Hexagonal system. Hexagonal crystal system. So here in hexagonal crystal system, what about Breve lattices? What about Breve lattices? So here hexagonal system only simple hexagonal, only the simple is simple hexagonal, that is P. Simple hexagonal, that is P. Hexagonal system, Breve lattices for this one, simple P. This is 1. This is also Breve lattices. In rhombohedral and trigonal only one exists. In hexagonal system only one exists. So what about unit cell characteristics? What about unit cell characteristics? A equal to B equal to B not equal to C. A equal to B not equal to C. Then alpha, that is beta equal to 90 degree. Gamma equal to 120 degree. A equal to B not equal to C. Alpha beta equal to 90 degree. Gamma equal to 120 degree. This is about unit cell characteristics of hexagonal system. This is very important for all physics entrances. For all physics entrances. What about hexagonal unit cell characteristics? Number of times the question asked this question. A equal to B not equal to C, alpha beta equal to 90, gamma equal to 120 degree. So examples in hexagonal system, uh, compounds: silicon dioxide, silicon dioxide, zinc, cadmium, nickel, arsenic. So silicon dioxide, zinc, cadmium, nickel, arsenic. These compounds exist in hexagonal crystal system. This is the fifth system. So Bravell lattices for this system only one, that is simple hexagonal. So what about unit cell characteristic? A equal to B, not equal to C, alpha beta equal to 90, gamma equal to 120. We are moving one more system here, that is sixth system is monoclinic. Monoclinic. Monoclinic system. What about Bravell lattices for this one? Monoclinic. So here simple monoclinic, simple monoclinic, that is P. Simple monoclinic, then base centered, base centered, simple monoclinic, base centered monoclinic, simple monoclinic, one Bravell lattice, base centered monoclinic, that is 2. So here Bravell lattices for this system 2. Bravell lattices for this system 2. What about unit cell characteristics? So for monoclinic, A not equal to B not equal to C. A not equal to B not equal to C. Alpha beta, alpha equal to beta, alpha equal to beta, that is equal to 90 degree, that is equal to 90 degree, but not equal to gamma. So what about unit cell characteristics here? A not equal, B not equal. These three are lengths are not equal. Then angle, what about angles? Alpha equal beta equal 90, but the 90 degree is not equal to gamma. So here what about examples? What about examples? So for example, for this one, for monoclinic system, copper sulfate 2H2O, copper sulfate 2H2O. We can call this one gypsum. Can call this one gypsum, copper sulfate 2H2O. One more borax. One more borax. These two are existing monoclinic system. Monoclinic system. See, I am discussing monoclinic system. The Bravell lattices for monoclinic system, that is simple monoclinic, base centered monoclinic. Two Bravell lattices exist for monoclinic system. What about unit cell characteristics? A not equal, B not equal to C. Alpha equal, beta equal 90 degree, that is not equal to gamma. So these are the examples for this system. Next one, seventh, triclinic. Triclinic. This is the last system. Triclinic means every go for lengths or go for angles. Both are not equal. That is for first of all we have to discuss Bravell lattices. For triclinic, Bravell lattices, see only simple triclinic. Simple, only one Bravell lattice exists. Only one Bravell lattice exists. So here, what about unit cell characteristic? A not equal to B not equal to C, alpha not equal to beta not equal to gamma not equal to, then that is not equal to gamma. Everything, neither is matched. A not equal B not equal to C, then alpha not equal beta, beta not equal to gamma, gamma not equal to 90 degree. So then what about examples? What about examples for triclinic? So here copper sulfate. So here I did mistake, calcium sulfate. Then copper sulfate 5H2O, copper sulfate 5H2O. Then K2Cr2O7. These two compounds exist in triclinic system. So I have mistaken here. Calcium sulfate 2H2O, that is gypsum, not copper sulfate. Okay. So these are the examples. I discussed here 7 crystal systems. I discussed here 7 crystal systems. So I will give one shortcut for this one. We can write easily, we can remember easily. So for this one, see, look here, C. O R H M T. See, cubic, tetragonal, orthorhombic, rhombohedral or trigonal, hexagonal, monoclinic, triclinic. So here Brave lattices for this one. Brave lattices for this one. 3. Brave lattices for this one. Monoclinic, cubic 3. Then tetragonal 2. Then orthogonal 4. Then rhombohedral 1. Hexagonal 1. Monoclinic 2. Last one triclinic 1. These are Brave lattices. Brave lattices. So 3 2 4 1 1 2 1. This is a code CTORHMT. 7 crystal system. Brave lattices for this system 3 2 4 1 1 2 1. Okay, over. So what about unit cell characteristics? A equal to B equal to C. A equal to B equal to C. Then alpha equal to beta gamma equal to 90. Okay, next. What about trigonal? Tetragonal. A equal to B not equal to C. Then alpha, beta, gamma equal to 90. See, I am not disturbing this one. Below is same. A equal to B. Then third system, A not equal to B not equal to C. Alpha, beta, gamma equal to 90. Since these three are not changing, first one A equal to B equal to C, A equal to B not equal to C, A not equal to B not equal to C. These are the changes for three systems. Then go for fourth system. A equal to B, that is equal to C. Then alpha, beta, gamma not equal to 90. Not equal to 90. This is repeating. A equal to B equal to C is repeated. Then alpha, beta, gamma equal to C. 3 are equal angles but not equal to 90. Next, A equal to B not equal to C. Then alpha equal to 90. Then gamma equal to 120. This is very hexagonal system, very important. Then what about monoclinic? A not equal to B not equal to C. Alpha equal to beta equal to 90 but not equal to gamma. But not equal to gamma. The last one triclinic, space is not that much, so I am writing here. A not equal to B not equal to C, gamma not equal to beta not equal to gamma. So these are the, that is not equal to 90. These are the simple technique. Here you can remember CTORHMT 32411121. So these are the unit cell characteristics. A equal to B equal to C. A equal to B not equal to C. A not equal to B not equal to C. Alpha, beta, gamma 90. Alpha, B, there is no change. Then fourth, A equal to B equal to C. A equal to B not equal to C. A not B not equal to C. A not B not equal to C. But what about angles? Alpha, beta, gamma not equal to 90. Alpha, beta 90, gamma equal to 120. Alpha, beta 90 not equal to gamma. Alpha, beta, gamma not equal to 90. These are the simple technique I explained to you, I given to you. Just remember. Thank you. Up to now I discussed 7 crystal systems. Then how many Brave lattices? 3 plus 2, 3 plus 2, 5, 9, 10, 11, 13, 14. 14 Brave lattices, 7 crystal systems. 7 crystal systems. CTORHMT. Cubic, tetragonal, orthorhombic, rhombohedral, hexagonal, monoclinic, triclinic. For that one, 14 Brave lattices exist. Thank you.